All right, so we're going to start Unit 8 today on simplifying radicals is our lesson for today. So to get started, I've made a list of all of the perfect squares from 1 to 15. So reminder, a perfect square is the product of a number times itself. So for example, we've got 1 times 1, 2 times 2, 3 times 3, 4 times 4, all the way to 15 times 15. So take a second and pause this video and write those perfect squares down. All right, so here's our procedure for simplifying radicals. So you're going to take the number under your radical, and you're going to find the biggest number in your list that's divisible by, that goes into 60. Okay, so I'm literally going to just take my calculator and type a bunch of stuff in. So 60 divided by, it's got to be smaller than 60. So we could try 49, but I mean, duh. 60 divided by, I'm not even going to try 36. I know that won't work. Let's try 25. Gave me a decimal. 60 divided by 16. Decimal, 60 divided by 9. Decimal, 60 divided by 4. Well, hey, that's a whole number. So now I'm ready to stop. 4 will go into 60 15 times. And so I'm going to take my problem. I'm going to rewrite it as the square root of 4 times 15. So I haven't changed the value of anything. All I've done is take this number and decide what can go into it. So 4 times 15 is 60. I always like to write the perfect square first because the square root of 4 is 2. And if you've done this correctly, the second number can't simplify, meaning there is no perfect square that can evenly go into 15, which if you take a look at our list, none of those numbers will evenly go into 15. All right, look at the second one, 1260. So I'm going to take my calculator. I'm going to take all these numbers and see what can I divide by 1260 and get a whole number. So this time you might want to start at the end of the list. 1260 is a pretty big number. So I've already worked this problem. So for the sake of time, I'm not going to type them all in. But when you get to 1260 divided by 36 is when you get your whole number. Okay, so 36 times 35. So I'm going to rewrite this as the square root of 36 times 35. Remember, I like to put the perfect square first because I can actually find the square root of that number. So the square root of 36 is 6. And then the square root of 35 I can just bring down. Okay, so again, I know I'm finished because there is no perfect square that will evenly go into 35. All right, look at the next one. So next we've got the square root of 108. So I'm going to come up here. Again, the goal is to find the biggest number that can evenly go into 108. So 36 times 3 is 108. And then 108 is also divisible by 9. And so I'm going to work it with both of these just so you can see what happens if you don't use the biggest one. But it is important to use the biggest one. So let's do the biggest one first. 108 is the same thing as 36 times 3. So I'm going to rewrite it that way first. Square root of 36 is 6. So I can bring down the square root of 3. I'm done. Okay, but let's say I knew off the top of my head that 108 was 9 times 12. Well, the square root of 9 is 3. Bring down the square root of 12. But I noticed the square root of 12, well, that's divisible by another perfect square. Okay, 12 is divisible by 4. So I can rewrite this again as 3 and times the square root of 4 times 3. I rewrote the 12. It's 4 times 3. Well, the square root of 4 is 2. So 3 times 2 times the square root of 3, which leaves me with 6 times the square root of 3. Okay, you are not wrong if you do it this way, but you're just going to lead yourself to potentially having to simplify it a bunch of times. Whereas if you find the largest perfect square you can, it'll always just be one step. All right, last one of these, the square root of 150. So I'm going to come up here. 150 I know is divisible by 25 because it's 50, 25. Okay, so 25 and 6. I think that's going to be the best one we've got. I know that because there is no perfect square that can go into 6. So I know I'm done. So I'm going to rewrite this. 25 on first, perfect square first, times 6. And the square root of 25 is 5. Bring down the square root of 6. Okay, that's it. Nothing more to it, not too bad. So if I wanted to take it up a notch, I could multiply two radicals together. And so really this doesn't make it that much more difficult. All you're going to do is multiply first and then simplify. So you're going to just literally multiply the numbers that are under your radical. 6 times 40 is 240. Stick them back under the radical and then simplify. Okay, so I've turned this now into the square root of 240. I'm going to find the biggest perfect square in my list that can go into 240. I'm going to try 16. 16. All right. So I got lucky. So again, sometimes you get lucky. Sometimes you've got to divide all the numbers, and whatever works for you is fine. So 16 times 15. I know I'm done because there is no perfect square that will evenly go into 15. Okay. So 240 is really the square root of perfect square first. 16 times 15. Square root of 16 is 4. And then I can bring down the square root of 15. All right, look at the next one. This one looks a little bit different. It already has a 2 on the outside. That 2 is going to stay on the outside. And then the only numbers I'm multiplying together are the numbers that are already under my radical. So 15 times 5. So 75. I know that one off the top of my head. 75 is just 25 times 3. 3/4. Okay, I remember I wrote my perfect square first. So the square root of 25 is 5. So I'm going to let the 5 be multiplied by the 2 that's already out there. Because all we're doing in this problem is a whole bunch of multiplication. I'm going to bring down the square root of 3. So my answer is 10 times the square root of 3. All right, look at the next one. Square root of 12 times the square root of 12 is the square root of 144. And hopefully you know that one off the top of your head. 12. Okay, so you'll notice anytime the number is the same under the radical, it's kind of like the radical just goes away and it's whatever the number is. Okay, we'll see another one like that in a minute. All right, and then last one, 6 times 18 is 108. We already did 108 on the front, if you'll remember. And so we said the best option for 108 was 36 times 3, which would be 6 times the square root of 3. All right, last one of those. So if you look at this one, we're going to do the same thing. The numbers out front get multiplied together. The numbers under the radical get multiplied together. So negative 2 times negative 3 is positive 6. And then 5 times 15 is 75, and I'm going to stick it back under a radical. Okay. Again, we've already done 75. I think that's an easy one. Hopefully that jumps straight to 25 times 3 in your head. Square root of 25 is 5. So I'm going to bring it out front with the 6 times the square root of 3. So that's 30 times the square root of 3. Okay. Again, it's never appropriate to leave your answer as a decimal. I always want them in simplest radical form. But if let's say, for instance, you wanted to check and make sure you had the right answer. Let's do one that's easy to type in. I can type in the square root of 6 times the square root of 18. And the calculator, all it's going to tell me is 10.39. But then I got 6 times the square root of 3 for my answer. And you'll see that they're the exact same decimal. So again, I didn't change the value of it. I just simplified it. All right, now for the fun stuff. The other thing you need to know is how to divide radicals. Okay, so there's 3 different things that could happen when you're dividing radicals. First thing, both the numbers are perfect squares, and you're just going to take the square root of them. That's what the case in example 10. The square root of 49 is 7. The square root of 64 is 8. So the answer is 7 over 8. You're done. Okay, look for that. If you don't look for that and you jump straight to the hard way, you're going to be frustrated. Okay, the second scenario is that the numbers are already divisible, and so you're just going to divide them and then simplify. Okay, so again, this is a case that you're going to forget to look for once I teach you the third case. Okay, but look at this. 16 divided by 8. Those go into each other. So the square root of 16 divided by the square root of 8 is really just the square root of 2. Okay, 16 divided by 8 is 2. They were both under radicals, so it's the square root of 2. Simple as that. I know I can't simplify the square root of 2 because there's not a perfect square that goes into 2. All right. And then the last case that could happen is that you're going to have to rationalize the denominator. You know you're going to have to do this if both numbers aren't perfect squares or if they're not divisible. Okay, if you can't simplify them that way. Here's how you rationalize the denominator. First, I'm going to take this problem, square root of 5/3. I'm going to rewrite it as the square root of 5 over the square root of 3. I like for both of my terms to have a radical instead of one big radical. When you rationalize the denominator, again, you're not changing the value. All you're doing is simplifying. But to rationalize the denominator, you're going to multiply by the square root of 3 over the square root of 3. The denominator over the denominator. Okay, so whatever the denominator is, that's what these numbers are going to be. So if this was the square root of 7, I would multiply by the square root of 7 over the square root of 7. Okay, and something divided by itself is really just equal to 1. So I'm just multiplying my problem by 1. So I'm not changing the value, I'm just changing how it looks. Hopefully you remember when you multiply fractions, you go straight across. So 5 times 3, square root of 15. Square root of 3 times the square root of 3, if you need to do it this way, is the square root of 9, and the square root of 9 is 3. But remember, since they're the same, it's just that number and you lose the radical. All right, so let's make sure we're done. Can I simplify the square root of 15? Is there a perfect square that can evenly go into 15? No, and 3 is a whole number, so we're good. Okay, so I'm going to do that again on this one. Multiply by the denominator over the denominator. And then you just go straight across. 4 times the square root of 3. I can't actually multiply those together, so I write them next to each other. And then square root of 3 times the square root of 3 is 3. Nothing left to simplify. I can't simplify 4/3. And the square root of 3 is in simplest form. Done. I do want to teach you a trick, though, so that you don't have to multiply by the denominator every time. It's called lose it on bottom, gain it on top. Here's what I mean by that. So I'm going to rework this problem. Lose it on bottom means to lose the radical on the bottom. So it just becomes 3. And then you're going to gain the whole thing on the top. Gain it. It doesn't become the top, you gain it. So what was already there stays. Gain the denominator on top. And look, that's what I got. Lose the radical on bottom, gain it on top. Gain the whole thing on top. All right, 2 more. Do we think I can do it? Let's see. All right, look at these. I'm going to multiply first, straight across. 8 times 6 is 48. 3 times 5 is 15. They're both under a radical. I'm going to see if 48 divided by 15 is the thing. Math inner. It simplifies to 16/5. Okay, always simplify your fraction if you can. So this is really the square root of 16 over the square root of 5. Okay, so now the square root of 16, well, that's 4 over the square root of 5. We know that it's not acceptable to have a denominator that has a radical. That's what we just did up here in these two. So we're going to lose the radical on bottom, gain the radical on top. Okay, I did that one quick. Multiply straight across. Simplify the fraction in my calculator. Square root of 16 is 4. I can't do the square root of 5. Lose the radical on bottom, gain the whole thing on top. All right, last example. Same thing. I'm going to multiply straight across. So 2 and 5 get multiplied together. That's 10. My radicals get multiplied together. Square root of 2 times the square root of 2 is the square root of 4. I'm going to write it that way for now. Over 18. Well, the square root of 4 is just 2 over 18. So that's 20 over 18. And I want it to be in simplest form, so I can type that in my calculator. Math inner is 10/9. Okay. All right, try your assignment for today. Remember, it is just a handout. I think you can totally do it. Good luck.